Okay, so you're probably watching this on a computer right now, but have you ever really stopped to wonder what's actually happening inside that box? Well, in this explainer, we're going to pull back the curtain on the technology you use every single day.
So yeah, we're going to open up that digital black box on your desk. By the end of this, you'll get exactly how it works, from the inside out. We'll look at what a computer even is, its physical parts, its digital brain, how they work together, and even the rules you're agreeing to just by using it.
Maybe you picture a laptop, right? Or your smartphone, or maybe that big gaming tower humming away under your desk. Whatever it is, it's a machine we rely on constantly.
But what if I told you the first computers weren't machines at all, they were people? Seriously, back in 1613, the term just meant a person who was really good at calculations. And get this, during World War II, the majority of these human computers were women, doing all the complex math that was essential for the war effort. It was only after the war that the word started to mean the electronic devices we know today.
Okay, so let's dive right in with the basics. To really understand the machine, we gotta know what it actually is. What makes the device on your desk a computer?
So here's the crucial point. Unlike, say, your microwave, which only heats food, a computer isn't a one-trick pony. It is a multi-purpose tool. You can program it to do countless different things. And that right there is the magic of it.
And how do they do all this? Well, they turn meaningless data into useful information. Think about it like this. A shop owner's sales numbers for the day, that's just data. But when the computer processes those numbers to show which type of bread is the most popular, now that is information the owner can actually use.
So every computer really has two core parts that work together in this perfect little ecosystem. Let's start with the physical half, the stuff you can actually hold. Let's talk about hardware.
It's simple, really. Hardware is everything you can physically touch, from your mouse and keyboard to the processor and memory chips that are hidden away inside the case. It's basically the body of the machine.
And we can sort all this hardware into 5 main jobs that they do for the computer. You've got your input devices like a mouse, processing parts like the CPU, storage like a hard drive, output like your monitor, and of course, communication tools like a router.
And we can break that down even further. You've got components, those are the essential guts inside, like the CPU and RAM that it absolutely needs to run. And then you have peripherals, those are the add-ons, like a printer or a keyboard that we use to interact with it.
But all that hardware is pretty useless without instructions, right? I mean, what tells it what to do? Well, that's where software comes in. Without software, your computer is just a very, very expensive paperweight.
So if the hardware is the body, then the software is the mind. It gives all the purpose and commands to the physical parts. It's that whole collection of programs and instructions that actually brings the machine to life.
Now, software itself comes in 2 main flavors. First up, you have system software. Think Windows, Mac OS, or even the Android on your phone. This is the foundation that manages absolutely everything. And then, on top of that, you have your application software. These are the programs you actually use, like your web browser, a video game, or a word processor.
And you're interacting with application software constantly. I mean, whether you're writing a report in Microsoft Word, figuring out a budget in Excel, or just browsing the web with Google Chrome, these are the tools that make the computer actually useful for us.
So how do the body and the mind actually work together? Well, it's all part of this beautiful, continuous cycle that's happening millions of times every single second.
Every single thing your computer does follows this fundamental cycle. First, you give it some kind of input. Then, the computer processes it. The result gets put into storage, shown you as output, and then finally, it can be sent to other people through communication.
Let's make this real with a super simple example. Imagine a teacher calculating student grades. This everyday task is actually a perfect illustration of the entire processing cycle in action.
Yeah, from a simple keystroke to a final printed report, every single step of the cycle is there. The teacher enters marks with the keyboard, that's input. The CPU crunches the numbers to get the average, that's processing. She saves the document, that's storage. And finally, she prints out the report cards, and that is output. See?
Okay, so we've seen how software works, but how do we get it? And when you buy a piece of software, do you actually own it? Well, not exactly. And this is where things get a little bit tricky.
Software comes to us in a few different ways. You've got the classic model, right? Buying it in a box off the shelf.
Then there's shareware, which lets you try before you buy. Freeware is free to use, but you can't see the code. And finally, you have FOSS. That's free and open source software, where not only is it free, but anyone can look at and even change the code underneath.
This all leads to a pretty major choice. Proprietary software, which is usually really polished and has official support but is restrictive, versus open source software, which is free and completely customizable but often relies on community support and maybe a little more tech skill. You know when you click Accept on an installation, you're not just getting through a boring screen. You are actually entering into a legal contract, an End User License Agreement, or EULA, and that thing defines everything you can and can't do with that software.
And ignoring those rules by using pirated software, that's not just illegal, it is a huge security risk. You're basically opening the door to malware, you won't get any of the critical security updates, and you could even face legal trouble. Honestly, it's just not worth the risk.
And that brings us to our final takeaway. Understanding your computer isn't just about hardware and code. It's also about the rules you agree to every single time you install something. So it leaves one last question for you. What exactly did you agree to the last time you clicked Accept?